Welcome once again to the second session for week 3. So for the first session, um, Cyndie took you through Starknet, explaining the features you need to understand, storage, trade, and all of that. She's going to be doing more detailed explanation on how I think she's going to be going through a bookstore smart contract today. Yes, so if you have like questions, make sure you always drop it in the comment section. So she would always like check back every time to answer your questions. Okay, so Joy, oh, we are allowed to still submit with yes, it's opened. It will close tonight, this night. So make sure for everyone that reached out to Cyndie, please, for week 1 submission, kindly submit your assignment before EOD. Thank you. So Cyndie, please, you can take over so we can get most of the session today. Thank you.
Okay, hi. Can you get
Hi, Cyndie. Can you hear me?
hello? Can you guys hear me?
Yes, yes.
Okay. It seems my network is flaky today. Let me just shut down the video so that it doesn't flutter. Okay. Okay, what about now? Can you guys hear me?
Yes.
Okay, awesome. So, hi again. Hi, people, GM. Welcome to the second session this week on smart contracts. So, actually, what we'll be doing is a little bit different. Let me first of all share something that I want you guys to go through. Copied. Yes. So I've shared the link to a spreadsheet. So we'll be going really deep into storage models in Cairo today. So we'll be writing several contracts, and then I'll take you guys through a bookstore contract I wrote when we get time because it's pretty long. But anyway, my major goal for today is by the end of this session, I want you guys to at least be able to visualize how the storage model works, and then we'll be talking about other things as we continue. Example, how storage mapping works and etc. Okay. Okay. Yes. My network is a bit flaky today, so I've decided to like shut down the video just in case, so that I don't go off as I'm speaking. But yeah, when I'll be occasionally turning it on so that you can see my very beautiful face. Okay. I think we can start in the meantime. Let me just quickly share my screen. In the meantime, please just go through you can, you know, open the spreadsheet and then I'll tell you guys what's going on. So let me just share my screen very quickly. Okay, it's down. It's down, so that's great. Let me just put this here like that. Okay, that's great. Yes, nice. I can see guys joining in. Okay. Okay, so again, welcome to session 2 for this week. We'll be going through smart contracts again, like I said. And okay, yes. So as usual, Cyndie, blockchain dev, advocate. So for today's agenda, I noticed when we were talking last session on Tuesday, I didn't manage to quite give you guys the picture on what I wanted to talk through with you guys about storage. Because like I said last week, once you start writing smart contracts in Cairo, understanding how the storage model works very deeply helps you in designing very efficient smart contracts, which first of all don't waste space, And second of all, they're optimized, okay? So that at least you can be able to use as low gas fees as possible. So with that in mind, for today's agenda, we'll go through the default storage model. By that, I'll show you guys what I mean in the spreadsheet, storing structs, how do you calculate a storage address hash, and how, when we execute a function, what happens. Remember last Tuesday, I had hinted at base addresses and offsets. So I'll take you guys through what that means. And also when you're dealing with maps, of which I'll show you guys with a real code example, what I mean. And also finally, when we get time, we can be able to go through syscalls. And then, yeah, where's that code? Okay. So I have written, initially I wanted us to go through this bookstore smart contract. So I'll share it as a gist. It's super long, so I saw it will take a lot of time. So in the meantime, once we are finished with all this, at least I can be able to give you guys a quick overview on what logic I've written in this bookstore contract of mine. But in the meantime, I want you guys, my end goal for this class is, by the end of this class, I want you guys to be to understand storage very deeply, so that even when you're writing smart contracts, you can be able to visualize what sort of values, what sort of data are you storing in the chain. Okay. Okay. With that, I think we can start. Yes. So don't worry too much about these slides. My main focus is this default storage. So let me just quickly check the chat to see. Okay. All right. Yeah, so you actually, just a second, guys, before I continue. So actually, you've already created the account. It's just that when you see deployed false, you haven't deployed it yet. So actually, it's good to go. I also noticed on my end, when I was creating like a new account contract to use to deploy to the smart contract, I'd get this internal error, either RPC URL or the network flag must be provided. But then when I check the accounts, I can find that it's already there. So in the meantime, I don't see any issue with it. When we continue, I'll share with you the list of the what is called the commands. But anyway, in the meantime, once you list the accounts and you can be able to see everything, every detail about your account. Example, it's in the Sepolia net testnet. You can be able to see the public key. You can be able to see the address, in which this address is what we use when you deploy your account contract, and also the salt. Actually, by the way, if you want, you can actually be able to set up the salt if you want, if you have a specific salt, and then the class hash, and then you can see deployed faults. So that means you've created an account contract, but you haven't deployed it yet. And by account contract, I mean let me just call it the wallet which you will use to like deploy your smart contract. But we're not talking about the smart contract in itself that you're deploying. But yeah, otherwise, I can see everything is good to go. Okay, so that's that. Okay, let's continue, guys. So, when we talk about storage, I don't know if you guys have gone through the Cairo book and you see somewhere where they say when it comes to storage, it's storage slots, and then it's a certain type of number, and then it's felts, etc. So many jargon, like I now normally like saying. Okay, so I decided to create this spreadsheet so that it can help you visualize when we talk about storage slots. What do we mean exactly? Okay, so before we even get to the storing struct, I wanted you guys to think of a default storage. Just think of this as let's say the default a Cairo storage model, right? Before we even start writing any smart contract. So as you can see, my first column here, I have something I call a storage slot address. So what does this mean? This just represents, it's a hash of it just represents the storage slots. Okay. As you can see, I have 10 storage slots, but essentially there are so many because it's like, I think it's 2 to the power of, forgotten. Is it 2 to the power of 2? Was it 250 what? Was it 252? I've forgotten, but essentially they have so many storage slots going on until down, right? That's where every person who's like writing a smart contract, that's where they store their data, right? So, but for the sake of this class, I have 10 storage slots, okay? So as you can see, this is an address. And then I also wanted to show like a decimal point so that for visualization, so that by when you say this, at least you know this is storage slot 0, storage slot 1, storage slot 2, all the way till storage slot 9. Okay. Yeah. So from 0 to 9. And then as you can see, since we haven't written any smart contract yet, so we haven't stored any variables. And by storing variables, I'll show you what I mean. As you can see, everything is just empty. Now, by default, every variable that you store using the, if you remember, every variable that you store using this, oops, let me just quickly write it here. Okay. Storage. I'm sure you remember this, guys. And then let's say X, let's say just give it to 32, right? Then we come back here. So this is now the storage variable. When you see XU32, when I talk about a storage variable, this is what I'm talking about. Okay, let me just in case anyone is saying. Yeah. So this is what I'm talking about. When I write X here is equals to U32, this is what I mean when I say a storage variable. Okay. So let me just, for the sake of, okay. So because we haven't written any smart contract yet, it's empty. Okay. Then, like I was saying, even if we've written X to U32, when it comes to storage, it's sort of converted into felt to 52. So each storage slot, per se, it has something we call 250, 252 bits. Yeah, so each storage slot, the first one has 252 bits, the second one 252 bits, like that. So even when you write here, my X is an unsigned integer 32, at least when it comes to now the storage, it's converted to 52 bits, okay? The felt to 52. So this is like the default type when it comes to storing on the storage model, okay? So as you've seen, most of the time, even when you're like interacting with smart contracts, and even when you're writing your Cairo code in itself, sometimes you find like the numbers are not exactly numbers. Like you'll find, let's say 0x0, 0. If let's say it's 12, of course I'm not, you'll forgive me, I'm not I haven't like mastered how the hexadecimal works. So let's just assume if it's 4, let's just put 0x4 like that, right? 0x7, things like those, 0x001, something like that, right? So this is how the actual value of your storage variable is stored. So if I come back here, this X of mine, if I invoke a function to it when I'm interacting with my smart contract and I tell it, please store for me the number 5. When it now comes to the actual storage where the value 5 is being stored, it's not stored as number 5. It's stored in hexadecimal. That's why I have this column here, actual value stored in hex. And then now for me, I decided to also add the readable format so that at least we have the hex and then we have the readable format like the text, okay? Now, address of storage slot hash calculation. Remember, this here is an address. It's just that I wrote them as 000 because it's the default, okay? So there's a calculation you have to calculate to be able to get this address, and of which I'll show you guys. So it's not just random, okay? So based on how you write your smart contract, every value that you decide to store it in the persistent storage, there's a way you have to calculate to get the exact storage slot that you will store that value in. Why is it that way? It's because when you go deeper into the design of Cairo and Starknet in general, you realize storage is not sequential. Just because I have a 0 from my storage slots from 0 to like a 9 doesn't mean that when I write like my first storage variable, it is stored in a storage slot 0, and then when I have my other variable, it is stored in storage 1. No, the sequential form of storing, that is in EVM. So you can also go and you can read up more on EVM storage model. So EVM, because it's a stack-based system, so you'll find that it's a bit more sequential, right? But when it comes to Cairo, they're all over the place, okay? So you might find, let's say, your first variable, example, let me come back here, right? So let me just quickly remove this. Let's say I have U, let's just give it 52, right? Like this. So with the way Cairo the Cairo model storage model works, you'll find like for example, you'll find your X will be somewhere around, let's say, storage slot 0, and of which most of the time, actually, when you get reacquainted heavily with how the storage model works, you'll find that most of the time it's not like storage 0. You can like store your storage variables in like slot 0 or something. You'll find most of the time it will be like slot 55, 66, 77, so many things, right? So, oh, okay. So let's just assume for the sake of the class, right? So we have our storage X. So you'll find it will be thrown, let's say, at slot 7, right? And then we come back to our storage variable Y. You find it's thrown to, let's say, storage 1. So it's not sequential. So that's what I want you guys to understand. So when you see me putting these tables, I just wanted you to see the storage slots, but bear in mind at the back of your mind that it's not sequential. Okay, so there's a specific way of how you determine the storage slot that you will get based on the values that you're storing in the chain, of which we'll get to see it later on. Okay. All right, so where was I? Yes. So I'll show you guys what I mean by address of storage slot hash calculation, because there's a way you calculate using either SN ketchup, have I written it correctly? Or desen hash. But I'll show you guys what I mean by these two hashes, okay? So we'll see it in real time. And then finally, this is just an extra, extra notes for me. So I've added some more extra notes to be able to guide us through everything, okay? So this is what by default storage will look like, okay? Yeah, so I just want you guys to see this and internalize and see, okay? So the first step is before we even get to storing a struct, I want us to write a very simple smart contract. Okay, so let me come here. Okay. So I had at least I have a history of commands, so we won't be stuck. Let me just come here again. Okay, let me make a quick directory. This is week 3. Oh, I have week 3 already. Week 3, patch 2. Okay, scab new. Let me just call it simple storage. Okay, have that. Starknet Foundry. Okay, change directory. And then okay, here we go. Okay, I'll update you later. Let me just put this here. In the meantime, if there are any questions, I'll be just looking at the chat. Let me just see. Okay, no questions. And for those guys who are coming in, just in case you see me, I've turned my camera off. It's just because my network is a bit flaky today. Oh my God, it's not even optimal. Okay, so let's come here and let's remove all this. Okay, so let's start. So the method I'll be doing is I'll be writing it so that you can be able to also play, go along with it. I might be able to, I might write it a little bit faster so that I don't confuse myself. And then I'll talk about it as I write. And then after we finish writing a sample smart contract, I'll share it in the chat so that you can just play around with it, reverse engineer. You can try and you can also try it by yourself and also maybe try to deploy also in your simple when we finish the class. Okay, so let's start. So what do I want to do? So I just want to store a single, let's just say a single value. So we'll write two sorts of smart contracts before we continue, right? So for this passages, okay, for this sheet here, actually, we'll just write a very simple smart contract so that at least on the back end, I can be able to take you guys through what's going on in terms of storing our value, okay? So just a very simple value. So like I said, we always start with the, oh, we always start with the Starknet interface so that I can be able to create the blueprint of what exactly, what sort of logic am I writing for my smart contract, okay? So trait, what should I call this smart contract? Store a single value. So trait I store single value contract, right? Yeah. T contract date. Okay. So what sort of logic do I want to add here? The first is I want to store a single value. Okay. So this means that this function will be a write function because we are updating our story. We are updating our state. Okay. So let's start on writing that. So function. So what should I call it? Function. Right? No. Function. Function what? Function. Write. Write single value. Okay. Let's just say store. Function store single value. Okay. And then F L T contract state. And since we're just storing a single value, let's just say A. A, what do I want to put it as? Let's say salt 252. Okay. And that's done. So we've written our first value. So it's very simple. We're going to store a single value A. Okay. And then for the next function, I want to read the stored value. Okay. So function read stored. Let me just write it out. Stored single what? Single value self. Okay, self. Stored. So remember here we're just reading and do we want to return? We want to return the type of this value. Okay, so we're going to return what? We're going to return a about 252. Yeah, it's a very simple smart contract. So we're going to only have two functions. Okay, that's it. So with that, at least we've defined our interface. So even if before we continue, we know we have store single value and then we have read stored single value. Okay, so we start writing ours. Oof, smart contract, Starknet, contract. Okay, so what did we call our interface? I store single value contract. So my smart contract will be called single value. Single value what? Single value contract. Like that. So we have our module. And already you can see it's complaining. Already the first error is contracts must define a storage struct. So like I said, when you're writing smart contracts, you can never evade storage. So it's best you understand it so that when you're designing your smart contracts, at least you can design having the storage model in mind. Okay. So let's start first of all with that storage. So we get it out of the way. So storage, and then what? Tract storage. Now, one thing before we continue that I want to talk about, when you're talking about storage, it's like you're limited. You can't call like this struct another name, let's say like struct store or something. Let's see what goes on. You see, plugin diagnostic contracts must define a storage struct. So when you're writing your storage, you just have to write storage. and of which, thinking as a developer, I find it to be at least easier. So you don't have to struggle thinking about how to name your function. So once you've written the storage attribute, you can now start this storage. And by the way, if you don't have anything to, maybe you don't have anything that you want to store into the persistent storage, you can just leave it blank. Provided you have this written down, at least your compiler will stop complaining. But in the meantime, if you don't have anything that you want to like store in persistent storage, you don't have it's not a must you write it. Okay, so let's continue. So because I've stored, let me see, store single value. So how will I name it? Stored, stored what? Oh, sorry. And then, okay. So essentially what I want is just to store the single value. Okay, so I'll just write it like that. And then after that, we start with the implementation. So we are starting to now implement our two functions, store single value, read stored single value. So let's do that. ABI, embed, version 0. Okay, let's see. Okay. Implement. So we start by calling the implement syntax. Okay, so you first write implement here, and then we're implementing what? We're implementing store. Oh, actually no. We're implementing this contract. Okay, so implement store single value contract. If you want, you can actually add impl. It's just syntactical sugar to show that you're now implementing your smart contract of store single value contract date. Okay, let's see what this error is. Okay, I need to import it. So here's super. Okay. So actually, we have two ways of importing because you see, if you remember when you were learning about how when something is out of scope, it's not you can't be able to access it, so you need to import it because essentially it's out of scope. It's implemented outside of our module. Okay, so that's why we have to import it. Okay, so let's see what this error is. Yes, not all trait items are implemented. Missing store single value. Read store single value. Yes, so now it comes to implementing our two. So we start with function store single, function store single value. Then it was out to 52. Okay, so remember here is since we're just dealing with a single value, the whole essence of this is we want to store this value here, A, in our stored single value. Okay, let me repeat that again. So the whole aspect of this function here is we have this variable here, we have this argument A here, right? Felt to 52. So essentially what we want to do is we want to write the logic that when we, let's say, deploy and interact with this smart contract, we can be able to write, if we decide to pass, let's say, A equals to 10, and then we need it to be stored. Once we pass it, we need it to be stored into stored single value. Okay, that's why here we're just going to say self, meaning our contract state, and then we call this stored value here, stored single value. Oh, have I written it? Okay, I've written it correctly. Store single value dot write A. Okay, so we have an error. Let's see. Ah, oh yes, I almost forgot. So there's something else which I'll show you guys why it's important. So let me just quickly write it. Okay. Image pointer, read access. Okay. Okay, so what's happening? Oh my God. I wrote store and it's single value contract. Yeah.
Think it's just a
Single
mistake
value
in the
contract.
spelling.
I'm sorry?
Stored single. There's no
Ah,
L.
oh yes. Oh my God, yes. Yes. Okay. So let me see. Okay, yeah, we are good to go. Thank you. I hadn't noticed I had misspelled it. Okay, so we are good to go, right? So with that, essentially, once we write this, of which I will show you guys with the spreadsheet, essentially what we're saying is when we pass in a value, let's say we pass, let me show you just here. Let's say we say store single value, and then we pass a value like 10, right? So the whole aspect of it, by saying right and by importing this storage pointer read access, storage pointer write access, this is where we now interact with something we call storage pointers, and of which in the spreadsheet I'll show you what I mean by that. So it's like we're telling it, please go to where we stored our store single value into the slot where we stored it, because the initial value is what? It's 0, right? It's not because we haven't passed any value to there. So it's like you're telling this storage pointer write access. It's like you're telling the storage pointer, please go to where we stored our storage variable, stored single value, right? And then update for it, update it to be 10. So that's why we have it there. Otherwise, if we don't like explicitly tell the smart contract to be storing every value we pass as A, it's not going to be stored. Even when you try interacting with your smart contract and you're like, okay, I want A to be 10, when you come and check the values afterwards, you'll realize it's still at default 0. So the whole aspect of the write function is you need to be able to explicitly tell the storage pointer, please go to where we stored our stored single value and update it for me to 10. Okay, so let's continue. Now the next step is where what function? Read. Okay, let me just copy it. Yeah. Okay, so here we're just reading it. So it's just self.stored. It does not store single value. Oh, have I written it correctly? Yes, dot read. Like that. Um, there's a reason why I haven't put like a just a by the way, if you've been working on Cairo, because we have something we call statement. Oh, okay, forgive my expressions. So because we are returning a value here, once you put this what's it called? Semicolon, right? It now becomes a statement. Okay, so that's why we're having this error here. If you can see, an expected return type. We expected a felt 252. We found like an empty value. Okay, so that's why we don't have this. If you want, also you can just also like oh God, oh, Oh, sorry. Have I written that correctly? Why is it not returning what I wanted? Okay. But in the meantime, that's what I was talking about. Okay. So the fact that we haven't put a semicolon here means it's now, it becomes like an expression. So you can also, like, as you continue reading, you can go see more about statements and expressions. But in the meantime, because of time, let's continue. Yeah. So our smart contract is okay. So let's first build it to see everything is okay. Oh shit. Okay. Let's check here. We see. Yep. So if it compiles to Sierra, at least you know for sure you haven't, example, handled memory wrongly. Otherwise, if there's a way we would have, let's say, misused storage or something, it would have not compiled to Sierra. So the whole aspect of Sierra is by the time you say your smart contract is outputting like a Sierra program, at least you know that you haven't like misused, example, something like storage. Okay. But one thing to note is, which I wanted to talk to you guys about, we might have written this smart contract, right? And so far we don't see any errors, but sometimes you'll get like you have logic errors that you don't know about. So that's the importance of tests, okay? Of which at least you'll be able to learn how to. Kaswini will take you guys how to write tests, okay? But that is the work of the test, because as you can see here, normally, I mean, because I'm not finding any compilation issues. So in my mind, I'll be like, everything is okay. But the whole aspect of writing tests is that to confirm in terms of your logic, is your smart contract doing what you want to do? Because remember, especially when you'll be deploying to the mainnet, right? And especially, let's say you're building like a DeFi, this is how people are able to, exploit vulnerabilities in your smart contract, because sometimes by the time you're seeing everything is okay, but maybe there's some vulnerabilities that you don't know of. Example what? I don't know if it will be applicable here. Integer overflows. So many let's say reentrancy. We have like so many vulnerabilities that sometimes we as developers, when we are writing like our smart contracts, we might be unable to overlook. Okay, so when you start deploying to the mainnet, at least try and write as many tests as possible, so that even if your smart contract is compiling, at least you still have you've written like the based on the test you've written, you've been able to test out what sort of output you wanted. And if the tests fail, at least you know there's some where you implemented the logic wrongly. Okay, so that's the important. Sorry, that's the importance of tests, especially since with a smart contract, it's not like a Cairo program where you interact with it you interact with it this way. You have to deploy it first, and then you interact with it, and then you see if it has like the results you wanted to. Okay, that's why we have the tests. Okay, so we've written that. So I just wanted to first show you guys this, and then we get back to our we get back to our spreadsheet. So of course, this spreadsheet I had written some other code. So let me just change it very quickly, if you guys don't mind. I can change it to whatever we. Okay, stored single value. Okay, so what's happening behind the scenes? Let's first of all focus on this area. Okay, let's just focus on this area first. So what's happening? It's okay. In our on of course, when we're writing the smart contract, in our minds we know that we've stored the single value, but behind the scenes, how exactly is this storage being handled? Okay, so let's come here. So we have our snippet, right? Store single value failed to 52. As you can see, before I showed you guys the default storage was like 000. But now when you look at it here, let me just finish. I can see so many charts. Let me just finish and then I'll go through the. Okay, this thing is so annoying. Where will I put it now? Okay, just stay there. Okay. So what's happening behind the scenes? First of all, you can see the slot address has changed. Okay, so it's not like the 0x000 that we had. It's a different slot address, and of which, just to by the way, this is not like the exact slot address. It was just a dummy hashing that I did behind the scenes, but we'll just flow with it. Okay, so we have this default, we have this storage slot specifically for our stored single value. Okay, so what I mean by that is our stored single value is stored. It's stored at this address. Okay. So what does that mean? When you start interacting with smart contracts, especially when you're going to like block explorers, etc., sometimes you'll find that you find like something is stored at, let's say, slot 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is just a readable. It's like a readable implementation of how this entire slot address looks like. So what this means is our single value here, it's stored at, let's say, slot 55,947. So this reinforces what I was telling you guys. It's not sequential. Okay. Based on what you're storing, you have to calculate this address so that you can find the slot. You can be able to like, of course, it's not you personally who's calculating this slot address, but now behind the scenes, what's happening. So once you write your stored single value, now behind the scenes, what happens is it's now used to calculate the exact place where your value will be stored. So there's no chance or anything. They've designed it so that it's very explicit. So everything you saw, it has its own storage slot. Okay. So like you see, oh, we've changed it. So let me change this again. It was what? It was stored single value. Okay. And it's felt to 52. So like I said, now stored single value in itself, it's stored where? Let's say in a slot 55,947. Okay. And what type is it stored in? Felt to 52. This means that even if even if we were to put like, let's say you what, 256, and yeah, just let me see. Let's just remove all this. Even if we were to store it as we were to pass a value which is a U2 to 256, when it comes to the storage slot, it's still converted to felt to 52. This is when I was saying each storage slot has what? 252 bits. Okay, so this other one has what? 252 bits. So what will happen is, example, you see this one, this storage slot of us, let's say it takes 256 bits. So what will happen? It will occupy all this space, this slot, and then here it will occupy what? Some extra 4 bits. Okay, so that's how it is. So based on how much bits the data you're storing, it will now take some slots. So example, for ours, it's what? 256, right? So it will take 252 bits, and then it's like that storage slot is what? It's full. So let's get back to somewhere else, and then we add 4 more bits. So that's what happens most of the time. So just also wanted to put it out there, but mostly you'll find it's felt to 52. So the actual value stored in hex, like I said, since we haven't like deployed our smart contract and invoked, or rather, we haven't passed any value per se to our stored single value, of course, it's going to be 0, right? But because I wanted to show you guys about hex, I put 0x0, okay? Now, here's what I wanted you guys to understand. So what did I mean when I said you have to calculate to be able to get the specific slot where you're going to store your value. Remember, we are storing stored single value, okay? So how do we get from here to an address, okay? So this is where now the magic happens. So we have this hash, it's called a SN Ketchak. It's like a variation of the EVM Ketchak hash, okay? So now that's why it has SN. So it's just a Starknet variation of how the EVM Ketchak hashing happens. So what happens is this hashing algorithm, right? It takes up our stored data and then it hashes it. And now this hash is what we have now here. Okay, so when you're writing, let's say when you come back to a smart contract and you're writing, let's say I want to store this, let's say I want to store another X, let me just use out 252. I want to store another Y, which is let's say U8. Bear in mind, at the back of your mind that every time I'm storing something, it will at the back of my mind I will have storage slot for stored single value, right? And how is it calculated? It is through SN, Ketchak, stored single, oh shit, stored single value, like that. So for here, that's now another storage slot. How is that storage slot calculated? We now have SN, Ketchak, X, okay? Okay, what about our Y? We have SN, Ketchak, Y. So every time you're writing a smart contract, I want you guys to always remember at the back of your mind, and remember it's specific for this. Okay, once you start storing values in the persistent storage, okay? So as you continue learning and you learn more about optimizations, actually, when you go to the Cairo book and you see like advanced smart contract concepts and you see storage optimizations, it's because the more stuff you're adding to this persistent storage, the more storage slots you're taking up, so the more expensive it becomes. Okay, and remember, like I said, you'll find some of these things. Each storage slot has what 252 bits. Right? So example for our Y, it will take an entire storage slot and it will take only 8 bits. So all the rest of that storage, what is 252 minus 8? Let me just quickly calculate that here. 252 minus, what is 252 minus 8? Oh my God. I can't think. Okay, what is, let me just write it down. 252 minus 8. 4. Yeah, 244, right? So the rest of the 244 bits is what? Is empty. But that doesn't mean that, let's say if we have like another one here, if we have like, let's say Z, well, 252, that it's going to take up this storage slot. It's not going to be like, okay, I have 244 bits here. Let me come and take up this entire storage slot. No, it will be left empty. Why? Because remember, even for Z, its storage slot will be determined by the hash Ketchak Z. So at no point in time will you find that two variables will be able to have like the same storage slot. So you see now we're wasting storage because we have our file 252 took to 52 bits, okay? We have our 256. Actually, this one took it overflowed, right? So it took an extra slot somewhere else with just 4 bits. So all the rest of those 248, all the rest of those 248 bits were left empty. So with our single code here, you can imagine how many storage slots we've taken because we started with our 252. That's one slot. Oh, let me just code it. 252. Okay, actually, let me just code it here, right? It will be much simpler to understand. So let's get back here. So we started with our stored single value, right? So you can imagine our stored single value first took what? 252 bits, right? And then it took another extra 4 bits in another storage slot, right? So we have that. So those are 2 slots already, right? And remember, the rest of all these other these 4 bits, it's out of 252 bits. Okay. Now we have our x took 252. Oops. We have our y took only 8 bits. Have I written it somewhere else? Yeah. Let me delete this. Okay, we have our x, right? It took 252. And then we have our, what was the other one? Our y. And it took only 8 bits. So meaning all the rest of that storage slot is empty, okay? And then now we have our z. And then it took another slot, 252. So can you imagine with only 1, 2, 3, 4, with only 4 variables which we have stored, you can imagine how much storage we've taken up. So we've taken 1, that's 1, 2, 3, 4, 5. We've taken almost 5 storage slots, right? So that becomes expensive as you continue. That's why it's important to understand how storage works so that when you're writing your smart contract, when you're designing it, at least you can be able to design with that in mind, that you want to use as least storage as possible. So if you're, let's say, adding 2 numbers, is there a point to add to store those 2 numbers in the chain? If there's no point, then well and good. There's no point in like writing that. Okay, let me just come back to our site. So like I said, for our stored data, right? Stored single value, you can see how was the storage slot determined by having the hash of the value in itself, stored data, right? Okay, that's good to go. So how exactly does this step happen? Of course, I'm just saying said ketchup and then stored data. Like what? How exactly are the steps which lead us to getting our storage slot address? So we come back here, right? So we have our variable stored data. The first step is you do something we call SC. Can I call it SC? SC encoding. SC encoding is this. Show you guys. Yeah, it's just converting your text into a bunch of numbers. Okay. So yeah. So that's how because essentially it can't be able to where's our start? Essentially, oh, okay. Essentially, it can't be able to encode stored data as a text, right? Because we're saying we are encoding stored data, like just how you've written stored data, right? We are creating a hash of it, but it's not going to be to take stored data the way we've written it, and then it starts with the creating a hash of it. So the first step is normally what you encode it into a bunch of numbers which represent this. Okay. So of course I took just some bit of random numbers. So let's assume we have this, right? So after encoding these numbers here, which represent our stored data variable, right? The name in itself, remember. So we now take our hash, the SN ketchup hash, and of which actually, if you want to do this, actually, you can just go to we have a lot of, there's a way when you go check it, when you go read the Cairo book really well, they've written out exactly how do you implement some of these algorithms. So they've put like methods so you can be able to use it. Okay. But now, in the meantime, we have our SN ketchup and it encodes these numbers that we've gotten after encoding our stored data, right? That's where we now get this result. Okay, so this is our slot address. Okay, and when it's converted to like a readable format for our sake, it's now like, let's say slot number 55,979 or something. Okay, so yeah, it's converted to a hash using ketchup. Okay, so that's it. So of course, we have our SN Ketchak stored data, right? There's something I wanted to introduce, which we call a final base address, and of which when we get to pointer offset, where here, offset, I'll be able to explain what I mean by base address, right? But for now, bear with me. So where were we? We were here. Yes. We were here, right? Okay, yeah, we were here. So, first of all, before you even get the storage slot per se, there's an intermediary we call like a base address. And as you can see, it's still the same value as the final storage slot address, right? Why is that so? Because now there's something I wanted to show you guys. Let's come back here. Let me just remove all these things. Okay, let's come back to our code here. So what do I mean by base addresses and offset? When you think about this code, I want you guys to imagine you in an apartment, okay? So X, okay, stored single value, X, Y, and Z. Those are 4 different people who have rented an apartment in your area, right? In the building. So of course, you're not alone in your apartment. You have 4 different people, okay? So let's assume everyone is staying on ground floor, okay? So stored single value, you'll find that when you want to give them like an address where even when someone wants to pick up things for you, like let's say you've ordered food online and you want it to like get into your place, right? So what happens? Of course, you're going to give out the address of where you stay. So you're going to say, I'm in apartment 1, floor 0, right? Okay. Our next person here, let me just oops. Okay, let me just okay. For Y, okay, for X, it will be apartment 2, floor 0, right? Something like that. So this guy also will be apartment 3, floor 0. Okay. So okay, apartment 4. Oh, okay, even 5. So when you're giving out your coordinates to the guy who's bringing you food, let's say Uber Eats, right? You're going to say, please deliver it to apartment 3, floor 0, right? So when we get back to our storage slot, this is now this I was talking about. You see this, where is it? Where is it? Where is it? You see this number here, this storage, Starknet storage address. This is now, it's like the entire the accurate map of where we've stored our storage single value. Okay, so just like how when you'll give out your details to the person who's delivering you food or even your friends, right? You'll say, come to apartment 3, ground floor, or come to apartment 3, second floor, first floor. So these 2 things here are what constitute this final storage slot. So what are these 2 things? Apartment 3 is now what I call the base address. Okay. And now floor 0 is now what I call offset. Okay. So to see this, let me just quickly go back to the offset thing. Okay. I think we'll need to like quickly, let me see how much time we have. Okay, we still have time. So that I can be able to visualize, to show you guys what I meant by set villager, only set what. Okay, offset 0, offset. Actually, that one will be, let's actually do different fields. Yes, let's quickly write this, actually. Yep. Okay, let's just write it here. Okay. So let's say I want to now store what? Yeah, let's just write the logic where we store, let's store two now. Let's store the three values, okay? Let's just misuse the storage. So let me just quickly write it out because of time. Again, I'll share these code snippets, by the way, and then you can use them as a point of reference as you continue to. Oh, sum of what? Sum of two. Okay, sum of two values. Oh, before I continue, let me actually check the charts to confirm. Before I continue, I haven't lost anyone. Okay. Okay. Yeah, you can actually have more than one lib.cairo file. What happens is we use something we call modules. Let me just quickly show you that. So let's say why am I not doing that? Let's say I want mod what? Two values. What am I going to call it? And then I come here. Yep. So that's how you have so the more you have more files, if you let's say want mod three values, and then you just come here and you do what? Free. Actually, why don't I do that actually so that I don't keep on yes. So let's just go here. Okay. So we can start writing our smart contract. So like I said, I want to store, let me just write it quickly. I want to store A, B, and their sum. That's what I want to do essentially. So let's quickly write it out because of time. So let me just start with Starknet interface, trade, oh, great. How had I written it? I store two values. E-contract Kate. Okay. And then so function add numbers. Add numbers. Okay, add numbers. Add numbers. Add the two numbers. Oh shit. And then we have our A. Let me just use font 252. And then we have our B, font 252. Okay, that's good. And then function get the sum. Yeah, get the sum. L at the contract state. It will return what I want it to return, another failed 252. Okay, we're good to go. Okay, that's it. And then we start writing our smart contract. So as you continue writing it, I'm sure by now you guys have seen these things a lot. Like example, when you're writing your Starknet interface, you can have your trait I store two values or two values. I store two values. Okay, you can even write it like store two values interface if you want to. But because it's very bulky, mostly you can just write it. And then for the trade contract state, and at least by now you can be able to familiarize with some of the syntax. As I continue writing, I think based on my experience so far, once you understand the principles of how Starknet works, how Cairo works, it becomes very easy. Like I've seen my friends say within 3 months, they've been able to quickly pick up Cairo. So I think as you continue, you can be able to like see it's really easy because you're not writing like a lot of things. You're basically just reading and writing to the storage, reading and writing to the storage. So once you understand the principles of how that happens, at least you can be able to hack, even write your own logic. Okay. All right. let's continue. So I had called it what? I had called it to values. Oh, yes, contract. Let me just write the contract here. Oh, the mod store to values contract. Okay, so let's start. Of course, let me just import the use storage. Oh, use Starknet, storage pointer. Yes, please. Storage pointer. Ah, no. Storage pointer read access. Okay, at least we've imported that. And then we also import our use super. But what I mean by super is essentially we're just saying, you're just telling the Cairo, import everything that we have implemented over here. That's why we always use the word super. So when you see super, essentially it just means import everything, okay? So use super, I store to values. Ooh. Okay, then we start writing our storage, tract, storage. And then, like I said, we want to store A, B, and their sum. Okay, so we store A, felt to 52. We store B, felt to 52. And then we store the sum of, let's just call it sum of A, sum of A, B, felt to 52. Okay. And then afterwards, we start implementing. So, where's my hash? Hash ABI embed version 0. Implement. Oh, sorry. Implement store to values contract of, at least with I store to values contract 8. Again, like I said, if you want to add, you can even add up play. Oh, how are we writing it? Was it simple? Yes. Okay. Yeah, missing add two numbers, get the sum. So we start with that very quickly. Function add two numbers. And since we are writing it, refer self P contract 8. Oops. A felt 252. B felt 252. Oh, sorry guys. Yep. Okay, so the way we will implement this is a bit it's a bit different, but it will still show you guys the whole concept of reading and writing to blockchain. Okay, because our function, we want to add two numbers. Okay, but remember first of all, we haven't inputted any number here. Okay, we haven't inputted A, we haven't inputted B. Okay, do you understand what I say? Like, we haven't inputted A in itself. We just said we want to store A, we want to store B, and then we want to store the sum of A and B. So essentially, everything is 0, 0, 0. Oh, okay. So how do we go about this? The first point is we write self dot self.a dot write. And then what are we writing? We're writing A. Okay. So this just tells our storage pointer, please, when I am interacting, when I invoke my smart contract, and then I pass a as, let's say 10. please update for me. Okay, that's what essentially it means. Otherwise, when I don't write self.write.a, I could have wanted to, if I wanted to actually, let me just show you guys. If I wanted to, I could have just written what? I could have just written, let what? Let what? Let sum equals A plus B, right? And then we do what? And then we update self dot sum. Okay. Self dot sum of A B dot write, and then we write sum here. This is still very valid, but do you guys get the gist here? Okay, when we try and invoke this add two numbers, when we're interacting with our smart contract, and then we write add two numbers, and then we say the call data will be 10 and it will be 5. Okay, the problem is we haven't specified anywhere that we want our A and B to be updated. So the sum will still be 0, because we haven't told our smart contract that, you know what, once I have my A as 10, please don't forget to update, because remember, we are storing it here. It's not like the other smart contract. Oh, we've removed it. It's not like the other smart contract where we were not storing A and B, So here we have to explicitly tell the compiler, please don't forget to do what? Don't forget to write whatever I pass. And what am I writing? I'm writing the value of A, right? Something like that. So let me remove this. And then self.b.write B. And then once we've written that, we're like, okay, at least when we get to this level, at least any point, any call data that we, any call data that we pass on when we are interacting with our smart contract. Remember on Tuesday when we were interacting with our smart contract, right? At least by here, our storage pointer, which I'll show you guys nextly what I mean by a storage pointer, will update A to be 10 and what? And B to be 5. So our sum of A and B, it will still be 0. So our sum of A, B will still be 0. That's because we've stored A, we've stored B, but we haven't shown the exact logic or what we are storing these values. What are we going to do with them? So that's what we're going to do right now. Okay, let sum equals A plus B. Okay, and then after we do that, we want this sum to be stored where? The sum of A and B. So self, and by self, I remember I said it's the contract state, right? So self dot sum of A, sum of A, sum of A, B dot write. What are we writing? We're writing the sum that we've calculated. And we're good to go. Let me just pause and confirm. No questions. Oh, right. I actually had misread the question. So you can't have more than .cairo file. Actually, that's why you saw here I wrote modules. So this is what we call modules. So you can only have one main lib.cairo, and then if you have other programs, because of course you'll be having very complex projects, right? So you organize them into something we call modules. So that's why you've seen I've put mode 2 values, mode 3 values, as you can see here. Example. So at least we can be able to have several smart contracts here, and then they can be recognizable because we imported them in the main lib.cairo file. Okay, so I had misunderstood the question, but essentially that's why we are doing this. Okay. All right. Okay. Let me see. Yeah, so like I said, okay, there's something you see here already. I love putting it there just for, just to look nice. But if you want, you can actually come here and you say super iStore. So that's just, yeah, if you want. But for me, I prefer importing it over here so that at least it's able to I can also not forget. And also it looks nice, like the code looks nice. It looks nice. Okay, but let's continue. In the meantime, 248, 44, okay. Yeah, so actually, when you now check, actually, when you go delve deeper, I haven't delved really deeply into how optimization works in terms of how there's a way you can bunch all these variables together, right? Because these are the storage variables. So there's a way you can bunch them together to be able to save on space. Yeah. Yes, so actually we are going here. Oh, how much time to, oh no. But I will show you guys at least how the map, because it's very important to understand how the map works. I'll show you guys how the map storage works, okay? So I wish I had written all these smart contracts beforehand, but let's continue. Okay, so let's quickly implement the other one. So where are we? Okay, so function. Our function is what? Function get the sum. Is anyone else seeing how time is really flying by? Like, I'm surprised it's 9:30. I thought it was like getting to 9 or something. Well, at, remember when we say at, we're taking the snapshot, okay? At contract interface. And what do we want to see? We want to see upload to 52. Okay, let me just quickly remove this. Oh my God, not contract interface, contract state. Let me just quickly remove this. All right. So here it's very simple. What are we reading? By the time we get to read the sum of what we've stored, right? What steps have we taken? Let me just reinforce that again. Okay. So we took we set the value of 10, right? And then the storage pointer updated the value from 0 to 10. And actually, let me show you guys something. Where is it? Yes. Remember, we still have this variable number. I mean, we have this variable where we have sum, we have A, we have B, right? And we say that's what it's used to create the storage address. It's okay. We have used this to create the storage address. So what are they storing? The exact value that you're storing, where is that? Yeah, the actual value you're storing is now stored in hexadecimal. So when we tell our smart contract here, please update for me my value from A to be from 0 to 10, it will go look for the storage slot. Based on, it will go look for the exact storage point using the address that we have generated, right? And then it will find it, let's say it will be, A will be, let's say it will be 0x0, right? And then it will be like, I've been told to update to update to 10. Okay, so what happens? It will now update to A equals to 10. But now let me just guess, it will be 0x10. It will not be 10 in itself. So remember, A is used to create the storage slot address, whereby the specific slot whereby the value which is passed by it will be stored, and then the actual value which you passed it to be stored, it will be stored in hexadecimal. That's why you always have to, first of all, give your smart contract access to be able to use this using the storage pointer read access, storage pointer write access, and of which when we talk to the when we get to the mapping, I think because of time I'll show you guys how mapping works, whereby we'll have the It's now what have I done? Okay. Storage map. It's a storage map. Read access and storage map, write access, something like that. But in the meantime, at least you've been able to see, right? That's why I keep on saying, once you understand how to read and write onto blockchain, you'll be able to write smart contracts very easily, because that's all we are doing, as you can see. So you write whatever you want to write, and then you write the logic that you want to happen, and then you update the storage. Okay, so let's write this very quickly. So it was self dot sum of what? Sum of A, B dot read. And that's it. So this is what I wanted to, so this is just another example of storage, right? So this is just what I wanted to show you guys. When I mean by offset and base addresses, what do I mean? Remember, like I said, each storage variable, this is now what we call storage variable, right? So A is treated separately. It's treated independently. B is treated independently. And our sum is treated independently. Okay, what do I mean by that per se? I think because of time, let me just quickly write the other smart contract I had thought of. So let's just go to 3 values, or should I just rename it to mapping, so that at least once we have that ready, I can be able to show you guys what I mean by independent. Okay, so yeah, mode mapping. Okay, let's come here. So what do I want to do? Let's just write a very quick smart contract. What do we want to do? We want to map what? Let's say now what we want to map. Let's say I want to map a user a contract address to their balance. Let's write a very analog like wallet, okay, to their balance. So if you type the user's address, you get how much balance they have. Ooh, balance they have. Okay, yeah. So bear with me, guys. Let me just quickly write it out because of time. So I show you guys what I mean by offset and the differences between how mapping in itself, it's the storage is being handled. Okay, so let's quickly start. So Starknet, oops, interface. So what do I want to do? Trait. I use a balance contract. And T contract state. Yes. Okay, so what functions do I want to add? So, function, we want to add a user and their balance, right? So this will be refer self, yeah, T contract state. And then now here is something we'll talk about, which is mapping, okay? So a key, I want my key to be, remember I've said if you type the user's address, so this will be our key. Okay, oops, sorry. Oops, oh, come on. You'll get what balance they have. This will be the value, okay? So what are essentially we're writing the key, in which our key will be contract address. I'll show you guys what I mean by that. And then our value will be what? Let me just use Volt 252 because I love it. Oops. Okay. Yes. Okay, type not found. I'll work on that right now. Have I written it correctly? Yes. Let me just quickly finish it out. Okay, so oh my God. I'm writing things so fast I'm forgetting we're still at the interface. Yep. Okay, function get what? Get user balance. Get user balance. User. So it will be self what? Equal the contract. Ooh, the contract paid. And then here, what are we using to get the use? Ooh, what are we using to get the balance? We're using the key. You see here what I wrote? If you type the user's address, which is the key, you get how much balance they have, which is the value. So what are we going to use here? We're going to use the key, which is the contract address. That's why I have the key there. And what is it going to return? It's going to return a value, which is felt 252. Okay, and we're good to go. So let me just quickly, so type not found. I need to import this. So let me just import it. What was the command? Use Starknet, contract address. Yes, we're good to go. Yes. So this whole aspect, it's just what is this terminology? It is used to like when you're dealing with addresses of people. Okay, so that's why I have put Starknet contract address. When you're dealing with addresses, you can use it. Actually, there's I don't think we'll be able to have time, but there's actually a get caller address, something like that. So sometimes it's normally it's used in several ways. Example, when you want to maybe capture the address which used to deploy your smart contract. Okay, so you use something like this. But for now, we're not going to go to that because we don't have time. So, but yeah, essentially this is just it. So okay. So I think we're good to go. So Starknet contract. Okay, mode. How have we called it? User balance. Oops. User balance contract. Of course, we start with the storage. Oh, yeah. Storage. And then we struct. How will I? Oh, yes, struct storage. So we want to store the users that we get, right? So here is where we now use something we call a map. Okay, because remember, I want to create a map whereby I can be able to store someone's contract address and the value will be in felt 252. So this is how the mapping looks like, okay? But to be able to use it, let me just quickly import it because it's complaining. As you can see, the error says, yeah, plugging diagnostic missing valid storage type trip from member type inference failed with cannot infer trait cost subnet first generic admin implement store mark type with sorry. Okay, let me just show you guys what this means. Okay, so there are two ways. Let me just choose the very easiest one that I know. Use Starknet storage. So this is what I was talking about. Storage map. Yes, storage map, read access. Storage map, write access. Okay. And then contract address. So I need to also use create call contract address. Okay, what else am I? Yeah. use super user balance contract. Okay, so I've done that. Let me see why. Okay, let me see why it's why could it be not working? Oh, right. Oh my God, I almost forgot, guys. I need to map. Yes, that's why I'm wondering it's not working. Yes. So I need to specify when I write use Starknet storage, storage map read access, storage map write access, map. It's like I'm trying to tell Starknet what sort of storage do I am I dealing with here? Okay, so I want my storage to be I want the values that I'm storing to be readable. I want them to be writable, and most importantly, I'm storing it in a map format so that it can be able to figure at the back of its mind, it can be able to know, okay, these users here, we're storing a map. That's why when I don't have this, that's why it's unable to figure out what is this map. So as you can see, it gives you several solutions. So implement store, and of which with implement store, you have to use that outside of the storage struct. Okay, so if we were creating like a struct users outside of this, right? And we want them to let me see. Let's just say it very quickly. Name. I want them to have a name. Let me just use felt 252. You can also use like byte array if you want, right? Byte array. Yeah. But let me just use felt 252. So with felt 52, it can be able to store characters up to 31 characters, right? If I'm not wrong. But yeah, so you can use felt 252. But if you're not sure, let's say if you're working with a string, right? If you're not sure if it's going to be long, just use byte array. Okay, so we can just leave it there. And then age, let's give it an age of what? Let's use felt 252. Offset, sorry, felt 252. Okay, so to be able to store, because let's say I wanted let me just quickly remove this, and then I'll just show you guys what I mean. Command Z. So if let's say I wanted users, something like that or something, of course it will bring errors, and then like I said, when you saw when we were having a map there, it gave some suggestions, right? You can either store using the Starknet store trait. So that's what I want to quickly show you guys. Derive. Okay, so don't worry about what I'm writing. No, just don't mind. I'll explain. Drop study, and then Starknet. Oh, yeah, something like that. Of course, it's going to bring an error, so yeah. So just wanted to show you guys what when you have structs which are outside, so you have to use this Starknet store attribute. But that was not part of our class, so let me just quickly remove it. Let me just show you guys mapping. Okay, so okay, so where did I go wrong? Yes, map. Okay, so now we are good to go. So let me just start writing the logic very quickly. ABI embed, yeah, embed version 0. So we are implementing user balance contract impl of with okay. I user balance contract 8. Yes. As you can see, yes. So we are good to go. When you see missing add user balance, get user balance. So let me just quickly implement that function, add user balance, and ref self t oh no contract state. And then we have our key which you've said it will be the contract address, and our value, which will be felt to 52. Yes. So let's start quickly implementing this. What do I want to do? I want to just I want to add a user, and by adding, I'm adding their key, which is the contract address, and I'm adding the value, which is their balance, right? So by the whole logic of this, essentially what I want to do is, if I want to call this contract, let me show you guys what I mean so that you can see the logic of implementation. If I call this contract when I'm interacting with my smart contract, essentially, I want to first add the contract address. So 0x1234, blah, blah, blah. And then I want to add the value, 1,000. So meaning the owner of this the owner of this address, 0x1234, I want to record that this is the owner, and the balance which is left in the the balance which is left in the address is 1,000. You see where we're going, right? So how do we do that? As usual, we write self, meaning our contract state dot users dot write. And then we write what? We write the key and we write the value. Oops. Simple as that. So as you can see, once you flesh out the sort of logic on what you're trying to do, it becomes easier because you're like, I just want to store this user as a map, okay? But I want to be updating this map with the key, which is the contract address, and the value, which is the user, okay? So it's that simple. And then when we want to like get user balance, sell at contract state, oops. And then, oh yes, and then the key, which is the contract address. What do I want to return? I want to return a felt to 52. How do I do that? I just say self dot users, right? Dot read. And what am I reading exactly? I'm reading the key. Just that. So this is how essentially you write the logic for when you want to map something to something. Okay, so don't forget the storage map read access, storage map write access, map. Okay, so just like how we had the previous one, storage pointer read access, storage pointer write access. This is a storage pointer that is, let's say, specifically for how it can be able to handle mapping. Okay, so let's just quickly start build, and then we get to where I can show you guys how the storage slots happen. What do I want to show? Wait. Oh, start build. Oh. Yeah. Okay. So we're good to go. Let me see. I hope I had written mapping. Yes. Oh, so I have self users. What was I writing here in the self users? Okay, let me show you guys what this means. Okay. So example. So I had tried out, of course, writing this smart contract before. So we have the self.users, right? Let me just write users. When we get back to our smart contract, right? We have these users. So this is what we're storing. Okay, so we have the users here, right? And as you recall what I said, to be able to calculate the specific storage slot, which will be used to store these users, what happens now in mapping? Remember, this is now not a standalone variables, as I was telling you guys. This is now we are mapping to related field. Okay, so what happens? So here, I'll show you guys what we mean by base address, right? So here we have our variable name users, right? What is the type? We are mapping our contract address to to felt to 52, right? So this is what we are mapping. So of course, there's no actual value stored because there's nothing which we've inserted yet, okay? So even in readable format, we don't have anything. The map is empty. The mapping is empty, right? So what is the first step when it comes to maps? So if you remember that the time when we had, let's say, you remember the storage, right? So we had A equals to felt 252, and then B was equals to like another felt 252, and then the sum was another felt 252, right? You remember the first step was we were doing SN ketchup of A. Oops. So here, the first step after you do this is something we now call, and of course, after you've encoded the A into ASCII, whatever, the first step is now the base address I was talking about. It's like when we get back to our apartment, what I was talking about, it's like you're given apartment, apartment 1, okay? Okay, so that's the base address, first of all. Then now, this base address, to create the storage slot now address, this base address, it's added with the offset. Just like how when you give someone your GPA, when you give someone your location, right? Uber Eats, you tell them you want them to deliver to the door. So you can just give them apartment 1 without telling them which floor it is. So this is what we mean by offset. It's just to be able to pinpoint the exact location whereby we've been able to store our values, okay? So it's just like how apartment 1, oh my God, it's gone. So apartment 1, floor 1. So base address plus offset, this is now what brings the storage address. So I want you guys to remember that. So when you see this storage slot address, the first thing is this base address here, it was using, let me show you guys. The first point was the SN Ketchak users, right here. The SN Ketchak users. So this is the first step. SN Ketchak users. So we get the what? We get the base address. Now, there's a very unique way that we can be able to get storage slots address for this. Let me show you guys. So after we do that, if you remember, there's something I called a Padesen hash. If you remember when I was starting in class, I talked about SN Ketchak, and then I talked about Padesen hash. And when you continue like reading the Cairo book, you'll actually start seeing Padesen hash. Even when actually you go check there's this chapter on built-ins. After you use like what's it called? After you use after you go through the smart contract and then you go through advanced and then you'll find there's some place. Is it the appendix or something? So there's something we call what's it called? There's something we call a Padesen hash. So I don't know. Country cousin, I can see you like you're writing. P, please. P A P A P A. What's P A? What's P A? PA, okay. I don't know. Are you guys also seeing the PA in my screen? I can see PA. But anyway, let me finish what I was talking about. So we have something we call the partisan hash, okay? So this now, this SN Ketchak, it's used for just hashing out very simple variables. Like they were just like the way we had our A 252. So to get the storage slot, essentially, you just use what? SN Ketchak, right? But now for a very complex data structure like we have here for mapping, this is now where the Padesen hash I was talking about comes in. So how does it look like essentially here? So remember the first step was we got our, let me just write it here again. So for our map, right? So the first step we did was SN Ketchak users. Okay, so what is the next step? The next step is to be able to get this partisan hash that I'm talking about, because this becomes what? This becomes the base address. So how do we get the storage slot specifically for a map? What happens is we now take the partisan hash. Yeah, let me just write partisan hash. And then we take the base address and the key. You see this key? Oh, please. You see this key? Where is it? Yes. You see this key? You see this key that I was talking about? This key, contract address. This is the key. This is the value. So what happens now? Because we're mapping keys to values, and essentially what we want is for every key that the storage pointer gets, it needs to be able to directly show where the value is. Okay, so that's why we have this. So essentially, this is how you get the storage slot for for a what? For a map. Essentially, this is what happens. So when you see this per se, this was what the base address was, right? As you can see, it's similar. And then we took what? Let me see. Okay. So what happens is, example, I've invoked a smart. Of course, remember when I said the map is empty initially, we haven't done anything. That's why the map is empty, right? Now here, I want to I want to write something. Like I want to write a contract address like I showed, right? You see this when we are, yes, add user balance, right? Add user balance. So what if I want to interact with my smart contract and I give it a command, the sncast command, and then for the call data, or rather, I'll say this is the function, right? Function add user, and then the call data. Let me just remember let me just see. Call data will be something like this. Okay, 0x. Imagine we are writing like a smart contract address, and then we want to show that this person who owns this account has 1,000 tokens. Okay, so what happens now behind the scenes? First of all, the first step, where's our users? SNKcheck users happens. Okay, gets the base address. Now, in mapping, I want you guys to understand something. In mapping, remember the map is empty, so it's not like we're storing anything. So this base address, it's like a placeholder. Let me just call it a placeholder, okay? Now, until you start interacting with the smart contract, of which we've called our function, add user balance, right? This is now where storage is now used. Okay, remember, before we even called this function, add user balance, our users was empty. Our users map was empty. Okay, so there was nothing to store. We've just said for any users who's updated, we want it to be a map that can be able to map what our contract address to the balance, so that anyone who wants to query and see, so does this address have so this address has what balance, so they just input the contract address as the key, and then they get their 1,000 as the balance. Okay, so remember something, when it now comes to the maps, remember it is empty, we don't have anything, so storage hasn't been used yet, right? Now what happens is we now take this Kachak users, this users variable here, right? So we get the base address. So this is like a placeholder. So this base address will be like, okay, let me just sit in. Let me see if we'll get any updates. But remember, we'll still have these users, but then when it comes to now the actual value, which is stored, there's nothing, okay? So we call our function add user balance. Where was I? Yes. And then we give it a 1, 2, 3, 4, 5, and then we say maybe there's 900. Okay. What happens now next is that to create storage for our map, our what is our logic? Let me just call it behind the scenes. Let me just call it behind the scenes. Behind the scenes, what happens? We have this placeholder here. right? So this is now where we introduce what I was talking about, partisan hash. And then it takes this base address. And then the key, this, let me just copy it. And then it hashes. The resulting, let's just say it will be 0x something. The resulting of this is now the storage slot, whereby it will be able to store our value. That's how it happens. So when the storage pointer, the map pointer comes in and it's like, okay, please tell me, what did we using this address? Let's just read it, right? And I'll show you guys what happens. So cell dot users dot read key. Let's say we've invoked this, we've used this. Well, yes, we've used like we've inputted this. We want to see what value, what balance this smart contract has. Okay, so what happens? The storage pointer will go to we'll go to this location, right? It will go to this location. And then there's a way to be able to know, oh, we have stored what? We have, for this storage slot, we have used what? We have used the base address and we have used the key, this key. So once it uses this, it will be able to just go directly to where we stored the value. So this smart contract, okay, this slot here actually, okay, actually I'm explaining it wrong. We already have the slot address. Okay, so this storage pointer will just go directly to where this storage slot was done what was saved. So this 900 tokens here, it was saved in this storage slot here. Let me see if I've confused anyone. Okay, but essentially that's what I wanted to show you guys. So when you're writing, once you start, let's say, writing a map, etc., just remember behind the scenes, your storage slot is being what? It's been converted. Is converted the right word? It's being acquired. It's being acquired using the partisan hash. Yes, but for simple values like the ones we had, whereby we just had like a felt 252, because they're just simple storage values, they're just storing them directly. This is where now we use the SN Ketchuk users. Oh, right. I don't know if we have more time, but yeah, I just wanted to show you guys that there's one thing before we see. Let me just quickly show you guys. There's something else. Remember when I was talking about offset, right? So let me just quickly just make a very dumb. Let me just. It of course it's because I'm just writing it. It might not work, but let me just okay. Let me go back to what I had made before. Derive what? Drop, because I want to drop it. I want it to be serialized. Starknet store. Okay. Tracked what? Struct user. So let's say the name, I want it to be byte array. The age, I want it to be filled to 52 something. What else can we add? Location. I want also to be by byte array. Yeah. So imagine now, let me just quickly just show you guys just a very quick thing. Of course, it will have errors, but I want to show you guys something. So when we now talk about offset, right? Sometimes you'll find you're dealing with very complex structures. Example, what if you're creating a directory? Okay, you're creating a directory of users and you want to show you've written this outside, right? And you want to show that for each directory of users, each user will have a name, age, and location. So what happens here essentially behind the scenes in terms of storage? So this is where we now talk about offset in a very, this is where offset really comes in. Okay, let me just show you guys. Yes. Okay. wanted to show you guys the offset, right? So how many remember when I was talking about this struct here for storage, I called this explicitly storage variable. Okay, and I said each one is treated independently. Okay, so if we have users, that's independent. If we have what? If we have, let's say if we had place, no. Let's just say we had place. This one is also independent. So everything that you write here, it's independent of each other. Okay, they might be working together, but behind the scenes, they're independent. Okay, so what if now I want to work with related data? Example here, because this is now struct fields. Okay, so every time we talk about a user, we have to talk about their name, their age, and their location. So how does the offset work here? Okay, so we'll still have our SN, Ketchuk. Okay. We'll still have our, let's say, our basic, right? But then, how does this struct handle, what is it called? Handle offsets. So, because this data is related, and when we want to use it, remember they're stored in very different places, right? We want them to be sort of interconnected. So that's where you find, example, let's go back to our apartment, will be like, so when you look at it, when you look at this scenario, it's similar to how, example, I had these people, okay? Let me just get back to the place. Oh, my just write X belt 252. Okay. This is now. Yeah, so this is buyer. No, this is, let's say, neighbor. No, this is renter one. Okay. So this is independent renter two. Okay. So if we had, let's say, another Y, this would be like another independent renter three. Okay. Remember, always remember that all these things, they might be related, but okay, they might look related, they might work together, but behind the scenes, they're treated as independent. So this one will have its own storage slot. This one will have its own storage slot. And this one will have its own storage slot. Like that, okay? And most importantly, the offset will be 0, okay? The offset will be 0. The offset will be 0. Why is it 0? Because they're independent of each other. Just like how I said, it's similar to this guy. Both of them, let's say all of them, they are in the same ground floor. So it's similar to this guy being in apartment 1, ground floor. Apartment 5, ground floor. Apartment 98, 9, ground floor. Something like that, right? So what's the difference between this tract and this tract? So when it comes here, still on the apartment, I want you to think of one person who bought 3 apartments. So instead of 3 people having 3 separate apartments, we now have this very rich person who bought 3 apartments in the same building. And let's say different floors. Actually, I should have written it here. Oh, what have I done? Have I changed? Oh, no. Yeah, one person who bought 3 apartments in the same building. Our user. Okay, our user. So, how are these buildings like? So, to understand offset, will be like, this is apartment 1. Let's say floor, still on floor 0, right? Ground floor. Let me just write ground floor. What does that apartment 1 mean? So this is like the base address, which you were talking about. And then the offset, which is 0, will now be used to create what? to create the storage slot address. That's one field. Now, we have another field, and by field, I mean user.age. Okay, that's what I mean by a field. So this is the field, user.age. Now here, I have user.name, okay? So this is like, let's say, apartment 5, first floor. Let's just give it first floor. So this will be the same base address. But now instead of offset 0, it will be offset 1. Okay? And this is what will now bring us the storage slot address. So they go, because to ensure that they are connected, they have to start from 0. And based on how you've written them, if it is age will start with ground floor, okay? Our first apartment 1. If it is name can't jump to apartment 3 without going through apartment 2. No, what am I saying? Age is in ground floor, okay? Sorry. So with name, it can't jump to the second floor without having going through the first floor. So that's what we mean by offset 1. So it will still be the same thing. It will be apartment 5, first floor, and then it will get the storage slot address. And then finally, user.location. It will be apartment, let's say apartment 3, second floor. And then this will be the base address, and then offset 2. And then it will be the storage slot address. Yes. So to finish up, why is the essence of this offset important? It's so that when you want to write to these pieces separately, if you want today to stay on the ground floor, if you want tomorrow to stay on the first floor, if you want tomorrow to stay on the second floor, example, if you want, let's say, to say user dot age, right? Let me write it correctly. User dot age dot write, and let's say you want to write the age, right? Or if you want to say user dot name dot write, and you want to write the name, just something like this. Let me just give you guys user dot location dot write location. So the whole aspect of this is all these things are stored in separate places, but because we've been able to be very explicit in pinpointing their location, you can be able to access and write them as independent. So if I want to just update the name, if I want to just update the age and I want to keep the name and the location to be the way they are, I can, because it has its own specific storage slot address, which was used by the base address and the offset 0. Okay. If I want to access the name directly, I have my base address and my offset 1. If I want to just directly add to the location, I have my base address, offset 2. If I want all of them to work together now, if I want this user to work together now, like example, I want to, after I have updated everything in its own separate field, and I want to now store user in itself here. Let's say here, user. At least this can be able to like pinpoint, okay, so we have our apartment. So at least it will help the storage pointer to be able to know we have a age in apartment 1, ground floor, the base address and offset 1. And then it's like tick, I got it. And then for the name, where have we stored it? We've stored it in apartment 5, first floor. Okay, got it. And location, where did we store it? Apartment 3, second floor. So that's where we have the offset of 2. So essentially, when you see like an offset 0, offset 1, offset 2, this just means you're working with related data. And mostly it's when you're having like data structures which you've built outside of the storage. But here, everything is independent. So even this users in itself, it will have its own offset 0. AX, it will have its own offset 0. why it will have its own offset to 0. Yes. Oh, that was a very long class, but I think I can stop there. So what I'll do next is I'll share this bookstore smart contract I had written some time back. Actually, I'm very interested to see how you guys will implement something which I've been wondering. So how I had written some logic here, right? This one, remove book. But then after doing some reading, I noticed it's I'm just updating my event that I've removed a book, but I haven't removed it from storage. So I think that's something you can learn. So it's okay. We are talking about updating things to storage, but what if I want to remove Y? Okay, not permanently from storage. Is it possible? Yeah, you can go do some, fun research. I'm also trying to do the same to see if it's possible. But in the meantime, I'll just share this as a gist because it's very long. I want you guys to go through it. And then based on this and all these other smart contracts that we've written them, I'll try and make them a bit prettier and share them. I'll share them in like a repo so you have as many implementations as possible. There's something else which we haven't gone through because of time, and it is a constructor. I wanted to like talk about a constructor. Is it written that way? Yeah, but we haven't gone through that. And also, events. How is events written? Is it written events? Yeah. So we haven't gone through this, but I had I'll write some very simple smart contracts just to give you reference as you continue learning more. At least you have as many smart contract implementations as possible. And also, don't forget the commands. My website, I still haven't been able to like finish it out because I got a bit stuck with work. But in the meantime, so that I don't waste your time, I'll just create another sheet here with example the smart contract deployment commands, which you can be able to use, so you can be able to quickly access them. And as you continue learning this, you can always come back here. I'll add more information because right now it's just tables because I made them with a lot of hurry. But I'll add some more reference notes down here so that at least as you continue learning about smart contracts, you can always remember the storage model, how it looks like. Oh, but in the meantime, I think, yeah, we've really gone through some comprehensive things, but I really just hope to God you've been able to understand something out of this. Yeah. Sarah, over back to you. Let me just quickly take some water.
Yeah, thank you. Thank you, Cyndie. I mean, your classes are always amazing. And yeah, we have come to the end of week 3 of our Cairo Bootcamp, but then always it's not always like the end because you guys will have assignments to do over the weekend before the next session next week. So next week we'll have Nathaniel talk about Starknet's development tools and framework, which he will dive deep into the developer tools like Scab, which is the package manager, then Stacklight, Starknet DevNet, and also Katana. Then also how to use Starknet Foundry. So if maybe you have tried exploring these developer tools and it's not like really working for you, the next session should be able to address that. Then in session 2, which would be on Thursday next week, Nathaniel will also do a hands-on ERC20 token contract. He will write ERC20 contracts on Starknet and also discuss other stuff, right? So if you I actually want to hear from someone, just one person. I want to hear how you think the bootcamp has been going so far. So if you want to speak, just raise your hand. And okay, awesome. Ebuka Musics. 1 minute. So you can just like make it brief. Yeah, I've asked you to unmute. Okay, yeah.
Okay, thank you very much. Good evening.
Yeah, good evening.
So from my own end, and I believe I'm speaking the mind of many, and the bootcamp have been going very, very well. The tutors are doing very, very well. Like the way they are breaking the explanation bit by bit, especially the today's tutor Cyndie. she's like breaking it in a very, very low level that we understand what
Awesome.
is really happening.
Awesome.
So I really appreciate both the coordinator, the mentors, and every other person.
Awesome. Yeah, thank you. Thank you for the amazing shout out. Cyndie, you're an amazing tutor, and of course we are looking at how we can expand how the bootcamp is and also a lot of stuff, right? But the end goal is to build on Starknet. As all of you here have seen, they are amazing product like that are building on Starknet right now. There's colonies, there's one ramp, and of course the end goal of doing this bootcamp is to have um like most of you build on Starknet's amazing products, and then at the end of the day they are during the last week we are going to talk about available funding that you can have a look and build on Starknet and a whole lot, right? But in the meantime, see you guys next week, and thank you, Cyndie. Thank you, Victor, that's country cousin, for the week from week 1 to week 3 so far, and we're looking forward to having Nathaniel on the next class. So see you all next week. Bye. And the assignments will be shared tomorrow, so you can do it over the weekend and submit by before the next class. Yeah, that's it. Thank you for joining, and do have an amazing night rest. Bye. Okay, what's the assignment? So the assignments will be shared tomorrow, okay? Collins, don't worry. I will share it
Yeah.
in the email.
Yes, please. So before I sleep, I'll make sure I look for like a smart. Essentially, it will just be implementing a smart contract. But for the sake of learning, because the next session will be on Tuesday, and based on what we've seen in previous boot camps, people start giving up when they don't understand. So it will be a very simple implementation. And when you have all these other reference smart contracts, of which now I'll share them tomorrow, to be able to guide you through, you'll be able to tackle it. So essentially, it's just a very simple smart contract that you'll just write and deploy. And then the deployment contract is what you'll just show. The website is still not yet live. Like I said, I got a bit held up with work, so I didn't manage to finish it with the time I wanted to. But in the meantime, I'll share as many resources as I can on
Yeah.
that. Yeah.
Yeah, thank you, Cyndie. That's pretty much it. So look forward to the assignment tomorrow in your email. So every information you always need can always be found in your email, or you can check the Starknet Africa Telegram group. But that aside, good night and see you next week and on Telegram as well. Bye.